So this is number 484, and it's about measuring the height of a tower, and then also how far you are from the tower, or how far Morgan is from the tower. So the first thing we're going to have to do is make a reasonable sketch. So here's the ground. Here's Willis Tower, right there. All right, and we'll make that the high point of the tower. And let's see, Morgan is walking along, so we'll say here's where Morgan is at first, and has an angle of elevation at the top of the tower, and it's 3.6 degrees. So there's the angle of elevation right there. And then Morgan walks 1 kilometer towards the tower, and now the angle of elevation has increased 4.2 degrees. And that should make sense. The closer you get to the tower, the steeper that's going to get, right? I was right there. That's pretty steep, so it's a bigger angle there. Okay. So let's see. What do we need? We need the height of the tower. So I'll label this one H. And we need to know how far Morgan is from the tower now. So that would be this length right here, X. All right. So let's see what we can set up. We've got these right triangles to work with. I'll call this A. This would be, I'll call this point down here C, and the point way up here. So we got a couple of triangles to work with. A couple of right triangles to work with. So let's set up an equation that we can use. If I look at the big triangle, A, C, D, this one's 3.6. This is H, and this is X plus 1. That's degrees. And if I look at the smaller one that fit inside of it, here's H, this is 4.2 degrees, and this is X, the right angle. So something we can set up is tangent ratios. So if I do tan of, we'll do the top triangle first. So tan of 3.6 equals H over X plus 1. And if I wanted to get like well, actually, let's leave it like that for now. And if I set up the second triangle, tan of 4.2 equals opposite H over adjacent X. And if you notice, it's not too hard to get the H terms by themselves. So then we would get X plus 1 times tan 3.6 equals H. And on this one, we would get X times tan 4.2 equals H. And since it's the same height in both cases, I can set the two H's equal to each other. So using substitution, we would get X plus 1 times tan 3.6, 3.6 equals X times tan 4.2. Okay. So we need to get X by itself, but there are two X terms. So let me distribute the tan 3.6 first. By the way, if you hate dealing with these, you can turn them into decimals, but just make sure that you store them in the calculator so you can use the long decimal versions and not worry about rounding errors. But I'll work it out with the tan 3.6 there till the end. So if I distribute that to the X and the 1, then I'll get X times tan 3.6 plus 1 times tan 3.6, which is just tan 3.6, equals X tan 4.2. And I want to get all the X terms on one side and everything else on the other. So I'll keep the X tan 3.6 on the same side. I'll move this one over to the other side so it becomes minus X tan 4.2. And then I'll move the tan 3.6 over to the other side so it becomes negative tan 0.6. And then I can factor out an X. tan 3.6 minus tan 4.2, right factor that x, equals negative tan 0.6. And to get x by itself, I'm going to divide everything by tan 0.6 minus tan of 4.2. So this side too. And then we can just plug that stuff into the calculator. So I don't have the calculator, I don't think, on this one, do I? Hold on, let me pause and find out. Oh, here we go. Okay, so I do have a calculator. So let me make sure it's showing up here. Okay, so let me go ahead and type in what we have over here. So that's going to be, first I got to make sure I'm in degree mode. So I actually don't know if this calculator is showing up on your screen, so I'm sorry if it's not, but I'm just typing in literally what it says here. But I'll put the numerator in its own parentheses, negative tan 3.6, and I'll divide it by, and then this has to go in its own parentheses so that it knows that's the whole denominator. So it's tan 3.6, and I'll close that 3.6 parentheses because it does that. And then minus tan 4.2. And then I'll close that extra parentheses, hit enter, and it comes out to be x is about 5.98, and the units in this case are kilometers. Okay, so now we have x. Well, it's not too hard to get the height at this point, because you could either use this or this. So I'll use the second one because that's easier. So x tan 4.2 equals h. So h is about, whoops. Yeah, hold on one second. Where's the red bar? There we go. H is about, what did I say? X 5.98 times tan of 4.2. So let me type that in and see what we get. 5.9. I'm just going to cut and paste that answer. Hit enter. Times tan 4.2. And we get about 0.43915 kilometers, which will be 439.15 meters tall. Oh no, sorry. Oh yeah, no, that's right. That's right. Okay, there we go. So hope that helps a little bit. And yeah, all right. Hope the calculator showed up too.